of many different subfields or concentrations. So two people who graduate in electrical engineering might go into two totally different career paths in their own subfield of expertise. The most common subfields you'll hear are electrical engineering is not just one subject. It consists of many different subfields or concentrations. So two people who graduate in electrical engineering might go into two totally different career paths in their own subfield of expertise. The most common subfields you'll hear are power, electronics, which are probably the two most common, then RF or radio frequency, also called telecommunications, and controls. There are other ones that I'll talk about later, but let's dive into what these subfields are, the careers you can get into, elective classes you might take, and senior projects that have been done. Power engineering focuses on the generation, transmission, and distribution of electric power. These engineers could work at an electric power plant when it comes to generating and distributing large amounts of electric power. They could work on solar energy or wind energy, or they could work on the power, electronics, and battery of electric vehicles. So if you want to make electric cars run further on one charge, then power might be a great concentration for you. So one of the electives you could take is power electronics. This is where you learn about control and conversion of electric power through electronics. For example, an AC to DC converter is a very popular power electronics device. Our wall outlets, at least in most countries, have an alternating voltage, which in turn creates an alternating current, or AC. If you want to charge your laptop, you need a constant voltage, like maybe 15 volts, which causes a direct current, or DC. So how do we go from that changing voltage to a constant one, or AC to DC? Well, inside all of our chargers, there's an AC to DC converter, which are circuits that change the changing voltage into a constant one to charge our devices. You'll learn various circuits that can do this. Don't worry about not understanding what this is right now. Just realize you will use circuit analysis techniques and electronics knowledge to then analyze these circuits that have a specific use. You'd also learn DC to DC converters, which are circuits that change one constant voltage to another. They are normally seen in mobile devices to maintain a constant voltage regardless of what our battery level is at. Then, as you can guess, there's AC to AC and DC to AC as well. These can be used in light dimming and emergency lighting systems, respectively. Now, these can all be used for so many more applications, but all these were the simple ones we can all understand. Power electronics can be seen in audio amplifiers, battery chargers, wind turbines, motors, and so on. There's, of course, way more to a power electronics class, but it's just too complicated for a video like this. Then you could also take an electric energy conversion class, which is essentially learning specifically about solar energy, wind energy, grid-connected systems, and so on. And there are other classes, but I'm going to move on to senior projects. But remember, every school will differ in the electives that they offer, but this is the overall idea behind the power concentration. Senior projects that students did in the power subfield include an energy harvesting bike that can convert mechanical energy into electrical energy, a solar panel tracker where the lenses could track the sun throughout the day so maximum energy could be converted, and a cell phone charger powered by wind energy via a small wind turbine. So hopefully you have a good idea of what the power concentration is. Now let's move on to electronics. This is about using electrical components to design various devices. These people design and improve our electronics, including computers, phones, radios, TVs, robotics, audio players, medical devices, and so on. This is probably what most people think of when they imagine an electrical engineer. But realize it's easy to look at these devices that use electronics and become interested. But you have to work with the electronics that make it work. You need to make the amplifier circuits, the filters, the oscillators, the logic circuits, etc. So an example of an elective class you might take is filter design, which I want to go into a little detail on. As I said in the computer engineering video, when something is receiving many different signals, like a radio antenna that's receiving many different radio stations at once, how do we remove the unwanted ones? Well, we have a filter circuit that blocks out or filters certain frequencies, but allows other ones to pass through. A simple filter circuit could look like this. Even if you don't know circuits yet, you can still see how simple these can be with just resistor and capacitor. This removes higher frequencies from a signal, but the consequence of being simple is that it's not very good. It doesn't cut off frequencies very sharply. There are many different radio stations, for example, and let's say we want to listen to 97.3 FM. We want a sharp filter that completely cuts off other stations and just passes the station we're at. If it weren't sharp enough and you were listening to that radio station, you might be able to faintly hear sounds from the other stations because they weren't being totally filtered out, and that would be pretty annoying. So larger circuits are needed, which allow for better and sharper filters. It's actually impossible to make a perfect square filter like above, but with more components, you can make a very sharp filter that mostly blocks out frequencies or radio stations that you don't want. And this right here is the basics of what a class like this would be like. What values do those circuit components have to be? What frequency would be the center one they're allowing to pass, like 97.3 FM from above? How would changing the values on the left change that center frequency? And how wide would this graph be, or what is the range of frequencies it will allow to pass? If it's too wide, it might let in other stations or frequencies that we don't want to pass through. You can also take an advanced analog circuits class or an op-amp design class, where you learn about other types of circuits like you did filters. But these are kind of tough to explain, like oscillators, phase lock loops, analog to digital converters, and so on. So don't worry about what those are for now. If at the very least you enjoy basic circuits, then you may really enjoy this subfield, because it's just using circuit analysis techniques to create circuits that have a specific purpose. So senior projects that people in electronics did include an analog audio amplifier, which would be used for a speaker, a car alarm system, a heart rate monitoring control system, or an audio distortion circuit that would enhance the quality of sound from an electric guitar by adding certain frequencies into the signal. Now moving on to RF or telecommunications. Communications, which is all about wireless communications and high-frequency systems. These engineers could work on satellite communications, radar systems, and high-frequency electronics for those radar systems all the way to quantum computers. Now, this is one of the most math-intensive paths you can go as any type of engineer. So before considering this, make sure you really enjoy calculus-level math, vectors, and physics, specifically with electromagnetic waves. Even if you have just taken basic physics in high school, make sure you at least enjoyed the electricity and magnetism portion. So an elective class you could take is digital communications, in which you learn how to take a digital signal and encode it into a wave to be sent off wirelessly. I've shown this animation before in which a voltage signal is encoded into an AM or FM signal, where you use that same technique but for a digital signal with ones and zeros, which, as you may know from other videos, is just a high and low voltage. We can't just transmit that as it is, so we take an alternating voltage and change its frequency for the ones and the zeros. You could also learn how to defend against someone trying to jam your signal by frequency hopping or jumping between frequencies that only your system knows. You could take an antennas course in which you learn about how antennas send signals and different types of antennas. This is a lot of physics and electromagnetic waves, like determining how current in a wire creates an electric and magnetic field at some distance away. Or you might learn how to predict how far a signal will travel based on the antenna parameters. You could take a high-frequency circuits class, which could be considered RF or electronics. But let me explain real quick why high frequency is more difficult and different than low frequency. If you attach a rope at a fixed end and started shaking it up and down very quickly, waves would start to travel down the rope. But then reflection would occur once they reach the end, and then those reflections would combine with the incoming waves, and it would get quite complicated mathematically. Well, when you have a very fast-changing voltage or high-frequency signal, like radio signals, TV signals, and so on, that you put into a circuit, the same thing happens. Current and voltage will travel down the wires, but will reflect back and cause complicated current and voltage equations within your circuit. Way too complicated to explain here, but that's the idea. So if you want to build an amplifier or a filter, it's not exactly the same as before because you have to account for those reflections. And this is another reason this concentration is so math heavy. Senior projects done in RF have included an RFID home lock, so you can open a door with just an RFID card reader instead of a traditional key, a remote controlled dish antenna, an alternative antenna to traditional Wi-Fi antennas for better wireless internet connection, a signal jammer that interrupts the signal from a remote-controlled car, and a wirelessly controlled robotic vehicle. And the last main subfield is controls. You really only learn the very basics of this in your required classes, and it is pretty math-intensive. Control systems typically use sensors that monitor some output, then those measurements are fed back to something else which makes corrections. For example, your car's cruise control continuously monitors your speed and adjusts accordingly if it changes. Without that feedback of your speed, if your car started going up a hill, the speed would not adjust. Controls can be seen in automatic driving, aircraft flight control, guidance and navigation for cars, ships, aircrafts, and spacecrafts, or temperature control and thermal regulation. Just think simply to air conditioning in the house that measures the temperature and turns the AC on or off accordingly. It's all control systems. The classes are more confusing, so I'm not going to go over those. Just know it is math intensive, but not quite as much as RF. Senior projects and controls include an airport runway heating system that would detect snow and ice buildup to ensure safety of incoming flights, or a seizure detection system, or an electric vehicle steering control system. Now, like I said, there are other subfields that I want to explain briefly as their own category. One being computer. You can specialize on the computer sides of things as an electrical engineer and take some of their elective courses, which I've discussed in other videos. Projects these students have done include a GameCube to N64 controller converter, a surge protector controlled by an Android phone that could turn off the surge protector and monitor electric usage to minimize energy consumption, and a lighting system that is controlled and monitored over Wi-Fi in which mobile devices could control the application. Optics is another subfield. This may be grouped with telecommunications, but I put it separately because it's kind of unique. It's mainly about using light to transfer data. Fiber optic cables use light to transfer data in computer networking as an example, or they can be used in sensors when it comes to sensing something like temperature or pressure. Projects included converting an electric signal to a light signal, then transmitting it through air over a short distance to a receiver, or an underwater audio transceiver in which visible light communications are used to transmit and receive the sound. And lastly, one more that I want to throw in is digital signal processing. This involves using computers to perform signal processing operations. So instead of having a voltage signal and putting it through a circuit to, let's say, filter the signal like you would in electronics, you have a sampled signal, kind of like taking pictures at various points, and you put it through a computer or digital signal processor to do the filtering, amplifying, and so on with those signals. One project was to create a noise-canceling device, so if someone is speaking into a microphone and there's unwanted noise in the background or whatever, the device could remove that noise. Filtering on a computer is much more power than filtering with just one circuit. And by the way, this is a math-intensive subfield too, because those filtering techniques are all math manipulation. And I'm going to end there because I've thrown a lot at you. So to summarize, various types of people with different interests may go into electrical engineering. You will have the same classes in the beginning where you learn the basics of all the main subfields I've talked about. But then students will find interest in different fields that they'll dive into. By their third or fourth year, students will be taking different elective classes from one another. And they'll also be working on totally different senior projects in their own areas of interest. Any of these interest you, then electrical engineering might be a great major for you. And you don't have to like them all. Many students in power, let's say, really hate RF. So don't worry if you don't like all the subfields. If you like this video, don't forget to like and subscribe, and best of luck on your search.
Team, I hope everyone is have joined, and we do have our like a lot of people. So we miss out Charbala. And who are all the other people about to join here? Akshaya, did you contact some of your friends to join?
Yes, sir. I will, sir.
Oh, okay.
Yes, sir.
Sargunan, in the meantime, can you check out whether your desktop is sharing or not?
Okay, sir. Okay.
Sure.
Sir, I hope my screen is visible now.
Yes, yes. Perfect. So you are about to take up the classes in this itself, or you are going to
No,
share
sir, no,
any
sir. I will share the
uh,
PPTs and I will share the dialect software. No problem.
fine, then, fine, fine, fine. So we'll just wait for another 5 minutes so that 2 to 3 people, I think so, they are missed out. So we can just
Okay,
pull
sir.
out the and we can go ahead. Okay. Until then, if you have any software videos which can be shared, then you can also share it, Sagnan. So even
Okay,
if it
sir.
is
But yeah, I just want to update one more thing. So those
okay,
who have downloaded the software, yeah, you can see manufacturers. You can see here. I think when you open the Evo software, it will appear like this. Okay.
okay. So during the session, you can just proceed with that. In the meantime, you can just share the car projects video too, so that would be more helpful. So like people can also know what's all about your company.
Okay. 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 Sir.
Do you have such
One minute.
videos?
Sargunan,
Take your
Yeah,
time.
money.
yeah, Money 100. Go to Google Chrome, Power Projects YouTube channel. You can play the corporate video of Power
Yeah.
Projects.
So yes, this is our channel, and you can see like different softwares like PV Assist, Homer Pro, and Inspection to E-Tab, Dixel Power Factory, and so on. So we'll get better ideas if you see the softwares. I mean, you can see the YouTube videos. So create our
Sargunan, second video.
this one, huh?
No, your network is very slow, Sargnan. So where you are from? You are not from office or you are from home?
Is it slow, sir?
Yes, yes. It is interrupted and it is buffering actually.
Okay.
If you can send me the link, I can just do it. You can share it in the chat itself so that I can copy it and share it right away.
Okay, I will share this link.
Oh, okay. Team, if everyone is there, we can start up the session. So who are all missed out actually? Akshaya? How many people are yet to join?
I think so. Ashika alone, sir.
Ashika. So what about she's from Kanyakumari, yeah?
Sir, we
Okay.
can start, sir.
Oh, okay. So again, she has a lot of trouble with rain and storm. Huh?
No,
Okay.
sir. Network is expired.
Oh, oh, okay, 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 okay. So she could not join in audio.
Yes, sir. No, sir.
She can at least dial the number and she can join, right? So she can hear
Yes,
it actually, in case.
yes, sir. Yes, sir. I will convey, sir.
Oh, okay then. Fine.
Okay,
Thank you.
okay, sir.
Power projects establish. Power Projects, established in the year of 2006, is a global power system consulting house in the power and industrial business for over a decade and is among one of the largest in its class. We at Power Projects are driven by quality and values. Our commitment at Power Projects is to exceed our clients' expectations, providing cost-effective and innovative solutions without compromising the quality of service. Our saga of success is simple, yet tough to be a world-class organization, adhering to process and quality at every stage. We at Power Projects have a committed team of 30-plus engineers and managers, dedicated and supported by state-of-the-art technology and industry standard process. The team comprises of a right blend of the young mind and seasoned expert, with expertise, technical know-how, and industry experience. We at Power Projects are expertise in all aspects of power business, like power system consulting, renewable integration, protection audit, safety audit, power quality analysis. Our experts are specialized in providing training program for industries and academic institutions in various areas of electrical engineering. We are specialized in providing engineering consultancy services like power system analysis such as load flow analysis, short circuit studies, motor acceleration studies, transient stability analysis, power evacuation studies for conventional power plants and renewables, network simulation and design, grid connectivity studies, grid code compliance, power system protection, such equipment protection, distance protection, differential protection for generators, transformers, fuse-bar, cables, overhead lines, restricted earth fault protection, arc flash studies, power quality analysis, such as harmonic analysis, sag swell analysis, flicker analysis, LVRT studies, overvoltage and insulation coordination studies, distribution network analysis, protection audit, safety audit. The mantra of Power Projects is understanding our client requirements and needs, organize, compile background research of the system for the various feasible solution based on the client requirement, formulate, determine solution specification, create, generate various feasible novel concept and examine, infer, settle with apt solution based on evidence and reasoning with the design team, design, detailed modeling with the team. Power Projects is equipped with high-end advanced power system analysis software and with the strong design team with key ideas for real-time engineering solutions. We are expert in the power system analysis tools like EDIP, Power Factory, PSSE, PSCAD, PVSYST, Homer. We are into major power business across the world in various process industries, utilities, conventional power plants, T&D, microgrid and energy storage, commercial building and renewable energy sector. Power Project team with the background of sound technical knowledge have successfully completed 100+ national and international projects across the globe. Few of our key project profile: 1,500 megawatt Al-Dabba PV solar plant Kuwait. Grid code compliance study for M120 Sembian wind turbine generator India. Power evacuation studies for PV solar plants in Malaysia. Power evacuation studies for 98 megawatt hydro plants in Malaysia. 2.5 megawatt fuel cell project at Intel R&D Center, Bangalore, India. Safety audit for 210 megawatt wind farm, Anathapur, India. Safety audit for 50 megawatt PV and wind farm for Terraform, India. Dubai Combined Cycle Power Plant, Saudi Arabia. Dubai Gas Plant, Ireland. FRA 54.3 Data Center, Ireland. Abu Hamar Mall, Qatar. Manufacturing Unit and R&D Center for Hero in India and Bangladesh. Our prominent client list. Power Project is equipped with 2 dedicated offices in Tirupur and Chennai. Our registered office in Tirupur has a seating capacity of 150 employees and a training room with a capacity of 50 participants. Our corporate office in Chennai has a seating capacity of 40 employees and state-of-an-art fully furnished library with more than 100 of latest standard books and crucial modeling. Power Project's single point solution for all your power system needs.
One moment. Sargnan, you can share now, right now. So I'll just...
Okay, sir. Okay.
Have you ever noticed how some people just light up a room from the moment that they walk in?
Yeah, can we start, sir?
One
Hey, good
moment.
morning.
So I'll just introduce you so that you can go ahead and talk on it. One moment, Saguna. So uh, students, actually, so everyone has joined the session or yet to join? If everyone is okay, then we can go ahead and start the session. So one moment, I'll just get the file. Okay, let's begin. So, good evening, friends. So, today it's again the second session, which is about to start with the simulation. So, which gives an insight of your propagations, where your real-time working is going to be there. So, it's something like we just want to throw light on certain areas where the actual platform is being simulated in a simulated software. So, this software is going to give wonderful idea about what is going around the electronic components or electrical components, how the voltage, current, and everything is being deployed, and how the equipment is going to work. So it is going to be presented by our power projects. So one of the partner of this internship. So SP Sargunan. So he is an engineer working with power system studies. He has completed his bachelor degree in electrical and electronics engineering from Annamalai University in 2019, and he did his internship at Power Project Chennai in the final year, and still then he has been part of the power projects. So he has hands of experience in load flow analysis, motor acceleration studies, power evacuation study, protection coordination, short circuit studies, arc flash studies. And his software knowledge is being extended to ETAB, DigiSilent, Power Factory, PVSys, and Dialax. So he has handled lot many projects. So a couple of it would be 220 kV NMDC iron and steel plant Chhattisgarh using ETAP 12.6 did the following studies: load flow and short circuit analysis. The second project deals with Petrochad Mathura Limited Petrofac Africa using ETAP 19.5 did the following studies on side circuits and relay coordination. The third projects include Atricia 50 megawatt solar power plant Haryana power evacuation study using ETAP 19.5, and the fourth would Neo Metallics Limited Durgapur motor acceleration study using ETAP 19.5. In the state of Qatar strategic food storage facility SFSF relay coordination using DigiStyle Power Factory. So he has a lot to add up, but I don't want to trouble the session. So all is yours, Mr. SP Sargunam. So you can go ahead and take up the session. Thank you. Sargunan, are you able to hear me?
Yeah, thank you so much, sir. Thank you for introducing me. Am I audible, right?
Yes, perfect. You can go ahead.
Yeah, thank you, sir. Okay. So, yeah, good afternoon, everyone. Nice to see you all. So, now I'm going to throw some lights on elimination engineering. So, using the Dialex software. So, Dialex is one of the software which is dominating the market right now. Okay, yeah, you can see when you type Dialex and when you get into it, this is the website of the Dialex, and you can see it is available in more than 25 languages. It has more than 190 lighting manufactured areas and so on. So we'll add more on Dialex once I get into the software. So if you want to download it, you can see here download Dialex. And Dialex comes up with two versions, and the latest version is the Evo 9, okay, and the earlier version is Dialex 4.13, okay. So if I want to do sports lighting, to do a lighting for any sports stadium like a football or a hockey stadium or any athletic grounds. So if you want to do that, still Dialex 4.13 is used. These features has not been updated in Dialex Evo 9. So yeah, so download both the softwares. Okay, and let me go to the software directly. So I don't want to bore you up with the concepts. So okay, let me start with few concepts and let me get into the software directly. Okay. So yeah, as you all know, light is a kind of an electromagnetic wave. Okay. Yeah. Yeah, I think you all be familiar with light. Light is a kind of an electromagnetic wave. You might be familiar with electromagnetic waves since your school days, right? So yeah, light is a kind of an electromagnetic wave, and the spectrum, it typically varies from 400 to 700 nanometers. There's an example for an electromagnetic wave from gamma rays to long radio waves, and yeah, the light is a part of it. Okay. So what are the sources which is available for lighting? The natural source and the artificial source. So when it comes to natural sources, the sunlight, the predominantly we use on the on the day. Okay, which is the sun, and similarly, yeah, moon, stars, and even some living organisms, like firefly and even lightning and so on. When it comes to artificial sources like incandescent source, luminescent source, and gas discharge source. So incandescent source is nothing but any sources which produces light due to rise in temperature. It's typically called as an incandescent source. A typical example is the traditional lamp which we use on the olden days, right? The tungsten bulb. I think you might be familiar with it, right? So that is an example for an incandescent source. So when it comes to luminescent source, which is exactly opposite to the incandescent source. So any sources which produces light without generating heat is typically called as a luminescent source. And the example includes LEDs and so on. So yeah, there are a number of luminescent sources like chemoluminescence, electroluminescence, piezoluminescence, and so on. You just Google it and know more about it. And yeah, LED is a very good example. Even the firefly, which I mentioned in the natural source, right? The living organism. Firefly is also an example for a luminescent source. It comes under chemoluminescence. Okay. So similarly, gas discharge sources, is nothing but electric discharge will be passed into one gas-filled environment where due to this discharge, it produces some light. An example includes, the metal halide lamps, sodium vapor lamps, mercury vapor lamps, and so on. Okay. So if you have any doubt at any point, so just stop me so that I will answer your question. Okay. So these are the different types of lamps, like incandescent lamp, fluorescent lamps, some of the lamps which is available in the market. So each of these lamps, has specific applications. For example, if I say, a halogen lamp, halogen lamps are typically used in headlamps in the vehicles. Okay. So similarly, when I say a metal halide lamps or a mercury vapor lamp, these are typically used in floodlights. Have you heard of floodlights? Hello.
Yes, sir, you can go ahead, sir.
Okay. Floodlights is nothing but, which is generally used to illuminate large areas, like a sports stadium or an airport or even a seaport or something like that. And so any areas which is very large, to illuminate such a large place, we use floodlight arrangements. Okay. So these metal halide lamps and mercury vapor lamps are typically used in floodlight arrangements. So I just want you to know, each of these applications of these different lamps. Okay, you just Google it and know about these different applications, and you know the reason of it. Okay. For example, if I say, as I already said, these metal halide lamps are used in a floodlight arrangement, to illuminate a large area. These are typically used in those areas because they produces higher lumens. When compared to all other lamps, LEDs are nowadays producing more of it. So, but when compared to traditional days, when compared to all other lamps, these metal halide lamps and mercury lamps produces higher lumens but consuming very less water. So these were traditionally used in floodlight arrangements. Okay. So I just want you to know about all these lamps, their applications, and the reason of it. Okay. So when I say a luminar, we technically call, we usually generally call it as a lamp, but technically we call it as a luminar. Okay. A luminar is nothing but a whole lighting unit. The lamp, the reflectors which is used inside the lamps, the ballast. For example, if I say a tube light, the tube light holder, the ballast, the starter, the fluorescent lamp, everything on the whole we call it as a luminar. Okay. So if I say a luminar may contain more than 2 lamps or 3 lamps. It is not necessary that the luminar contain only 1 lamp. Now, so yes. Similarly, IP rating. Since you all come from electrical background, I think you might be familiar with IP rating, ingress protection, right? So IP rating is nothing but even every electrical equipment has an IP rating. The word ingress means something which is entering into an object. It's nothing but ingress. Okay. So a typical example of an IP rating look like this. Okay. IP65, you can see here at the bottom, right? So it is nothing but it tells you how the object is protected from the environment, from the outside environment. For example, you can see here the first letter, the first letter IP refers to the ingress protection. Okay. Similarly, the second, the third letter you can see here, the 6 refers to the solid protection. Okay. You can see here it varies from 1 to 6. If I say solid, IP1, it protects the object which is greater than 50 millimeter. It protects the equipment which is from the objects which is greater than 50 millimeter. So similarly, if I say IP rating 2, it protects the objects which is greater than 12 millimeter. So if I say 3, IP rating 3, it protects the object which is greater than 2.5 millimeter. A typical example would be a socket. Okay. So if I cannot insert my finger into a socket, but I can insert a screwdriver into a socket, right? So you just explore this IP rating. Okay. If you didn't know about it, you just explore, every electrical equipment, including your a laptop or a cell phone, every equipment is an IP rating. Okay. It is not only the transformers or switchgear rooms and something like that. Every electrical equipment has an IP rating. Okay. Similarly, when it comes to the second part, the liquid part, it protects the objects like it varies from 1 to 8. And if I say 1, it protects the objects from the the water which is falling vertically, So if I say 2, it protects the objects which is if the object is tilted to 1 degree or 15 degrees. So similarly and so on. If it is 3, if it is splashed over all the areas, if it comes with a jet, with a powerful jet, and if the object is even completely immersed in water, it even protects the equipment. For example, if I say if I have to give an example with the help of a luminar, there are some lightings which are used in the swimming pools, right? Which will be inserted into the swimming pool. So that will be a very good example for an IP rating 7 or 8. So similar to IP rating, there is also something called IK rating, which is called as impact protection. I just want you to explore it. Okay. IK rating. Okay. So yes, when it comes to lighting, we generally classify it into 3 types. One is the ambient lighting, the other one is task lighting, and the final one is the accent lighting. Okay. So ambient lighting is nothing but any lighting which is used for a general purpose. Say, for example, if I'm using a lighting from, for my living room or a bedroom or for my office. So that is a very good example for an ambient lighting. So yeah, you can see here, like, the recessed lighting, the wall scones, and the chandeliers. So recessed lighting is nothing but, the lighting will be inserted into the ceilings, which is nothing but called recessed lighting. You can only able to see the lighting part, but you cannot be able to see the lamp holder or the electrical wire or something. So that is typically called as recessed lighting. Okay. So similarly, wall scones, the lighting which is fixed onto the walls is called as wall scones or wall lighting. So similarly, chandelier, you could have seen in like big malls or some big places you could have seen, like, which is used for a decorative purposes, like this chandeliers. So these are example for ambient lighting. Okay. So similarly, task lighting. Task lighting is nothing but any lighting which is used for a specific purpose. To achieve a specific purpose, it comes under task lighting. For example, if I'm studying with the help of a desk, So I'm using a desk lamp to study. So that is an example for a task lighting. So, or else, a surgeon, a physician, which is, operating inside a human body in an ICU room. So he uses some lights to illuminate on the operating part on the human body. So that is an example for an task lighting. Okay. So yeah, you can see here like pendant lighting, desk lighting, and under cabinet lighting, which is typically used in the kitchen areas to illuminate in the kitchen part. Okay. So yes. Similarly, accent lighting. Accent lighting is nothing but any lighting which is used for decorative purposes comes under accent lighting. So say for example, if I'm illuminating my say for example the shopping mall, the illumination which is given on the outside part of the shopping mall is called as an accent lighting. Or say for example, I'm having a statue, okay, and I'm illuminating the lighting part on the statue. So that is an example for an accent lighting, or a wall picture to illuminate the wall picture. So these comes under accent lighting. So any lighting which is used for decorative purposes. So simply comes under accent lighting. So yeah, you can see here, the wall pictures which is illuminated with the help of these track lights, and similarly the spot lighting which is used in theaters, and similarly the landscape lighting which is used on the outside of the building. Okay. So yes, these are some of these softwares, which is used in the market right now. Like Dialects, Calculix, AGI32, Radiance, like Calx, Wavefront, and so on. But why Dialects is dominating the market when compared to all other softwares? The first and the primemost reason is, it is a free software when compared to all other software. Some softwares are paid softwares. Most of the softwares are paid softwares. But Dialects is a free software. So that is one of the major advantage of Dialects. And the second most important reason is, it has more than 190 lighting manufacturer data. So, I think I could have, emphasized this point, once I get into the, yeah, you could have seen here, it has more than 190 lighting manufacturer data. Okay, I cannot able to find it. Okay. So it has more than 180 lighting manufacturer data in it. So that is one of the major advantage of Dialects. So when I see, you can see the second software like Calculix, right? The Calculix is software which is provided by the Philips company. I think most of you have heard about the company called Philips, right? So if I go with the Calculus software, I can only use the Philips catalog. Only Philips catalog is available in the Calculus software. So I cannot, so say for example, I'm doing a lighting designing for a commercial building, for a very large commercial building. I cannot go with a single manufacturer, okay? I cannot go with Philips alone. I have to go with a different manufacturer. So for that advantage, I can only go for Dialects. I cannot go for a Calculix or something, okay? So yeah, as I already said, Dialects is the software which is produced, which is created by the company called Dial, 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 which is a German-based company. Now, as I already said, it comes into 25 languages and has more than 190 lighting manufacturer data. So these are some of the standards which is available in the market. For example, the first standard is the European standard. EN refers to European. EN 12464. The one refers to, it refers to the indoor areas, and the EN 124642 refers to the outdoor areas. Okay. And similarly, the DIN standard, the third one, DIN standard is a German standard, and the CIE standard is an International Commission on Illumination. It's an international standard. And similarly, IESNE is an American standard. Okay. It is abbreviated as International Nation Engineering Society of North America. Now, so similarly, SAI is, it's the Saudi Aramco Engineering Standard. I think most of you have heard about Saudi Aramco company. So similarly, the final one is the Indian standard. IS is the Indian standard, IS 3646. Okay. So the first five standards, starting from European standard to the American standard, IESNE, has been adopted by the Dialect software. So broadly, lighting, the technical part, technically we call it as illumination. Okay. So when it comes to lighting design, there are three main aspects. the first aspect is the illumination part. How much illumination I'm acquiring on my working plane or my given area. Okay, that is the first part. And the second part is how energy efficient it is. Nowadays we are talking about global warming, climate change, and so on. So nowadays they are even giving importance to those parts. Okay, so even there are some green initiative programs like LEAD and USBSE and so on. So these are some of the green initiative programs which are providing some some incentives. So if your building is energy efficient, okay. So yeah, the second important thing is how energy efficient it is. I know how much power it consumes on a whole year. So that is the second part. And the third part is the aesthetic effect. How beautiful it is. Okay. So similarly, when it comes to lighting, it is not only the artificial light which I'm denoting. It is also the natural light. Normally in the morning, we don't use artificial lights predominantly in our houses. We only use when with the help of sunlight, we'll be able to achieve the required illumination in our area. So similarly, yeah, when I say lighting, it is not only the artificial light; it also includes the natural light. So yes, these are the four basic terms like luminous flux, luminous intensity, illuminance, and luminance. Okay, I think most of you studied about these parts, but still I will revise. So luminous flux is nothing but the luminous energy which is emitted from the lamp or a lumina. Okay, so which is the unit is lumen. We denote it as F, luminous flux. Okay, which is nothing but the luminous energy which is emitted from the source. We call it as luminous flux. We denote it as F and the unit is lumen. So the luminous intensity is nothing but the luminous flux which is falling on a particular angle. Okay. So the luminous flux will not be same throughout the angle. It varies from angle to angle. Okay. So luminous intensity is nothing but the luminous flux which is falling on a particular angle. Say for example, you can see here in the small lamp, you can see here the light which is falling on the particular, this conical angle is nothing but the luminous intensity. Okay. So we call it as I, luminous intensity, which is equal to luminous flux on a solid angle. Okay. We traditionally call it as candle power. We usually calculate this luminous intensity with the help of candle. So we also call it as candle power. Okay. So traditionally it was the candle power was a unit. It was one of the unit, but nowadays it is not being used. So luminous intensity is otherwise called as candle power these days. Okay. So the unit is candela. So the SI unit of this luminous intensity is candela. Okay. So illuminance is nothing but the luminous flux which is falling on a particular area. Okay. The luminous flux which is falling on a particular area is called as illuminance, which is denoted as E, and we call the unit is lux. Okay. The flux which is falling on a particular area, lumen per square meter, which is also called as lux, or the other unit is foot candles. The non-SI unit is the foot candles. Luminance is nothing but the the luminous intensity which is emitted or reflected from a particular surface is called as luminance, which is nothing but luminous intensity on a given area. Okay, which is candela per square meter. So these are the four basic terms, and you must be familiar with these terms. Okay. So far, if you have any doubt, you can ask me, or else I can go with the dialog. So. Hello. Hello. Hello, Bala sir.
So yes, tell me, sir.
Yeah, okay. Am I audible, right?
Hello.
Yeah, I'm audible, right?
Yes, sir. You are audible, sir. Clear, sir. You can go ahead.
Yeah. Okay. I think students don't have any doubts, so can move on, right? So if you're down, okay. Yeah. Thank you so much, Purnima. No doubts. Okay. Thank you. So let me go to the dialog software. Okay. So this is the dialog Evo software. Okay. You can see Evo 9. So once you open the software, you can see here. So first it says like outdoor and building planning, import the plan, room planning, street lighting, and so on. So before that, I will just tell you one point. First go to manufacturer, and you can see here different types of catalogs. As I already said in the PPT, the dialog software comes with more than 190 lighting manufacturer data. So these are the manufacturers, lighting manufacturers. So you can download these catalogs, okay? So I prefer you to download the Philips catalog, okay? Because I think it comes with less MB when compared to all of the lighting manufacturers, okay? So better you download the Philips catalog or Airton or something, okay? So let me start with an indoor lighting. So now I will do I will do a lighting design for a classroom, okay? So you can see here, you can see once you open this Evo software, you can see this window appearing. So you can see like outdoor building and planning, which is used for the outdoor areas. So this is nothing. The second option, you can see like import plan or IFAC. So if you want to import an AutoCAD file to do the lighting design, you can use this option. So the room planning you can see here, which is used for the indoor planning. Okay. So street lighting, if you want to do the street lighting, you can do the street lighting. And if you want to do one simple indoor planning, you don't want to complicate it, you just want to do a simple one, you can use this option. So I will now go with this room planning. Okay. Yeah. So yeah. So I'm going to do this lighting design. I'm going to incorporate this this classroom. I'm going to do the lighting design for this classroom. Okay. So you can see here, this is a classroom of about 9 meters length and about on an average of about 6 meters in width. And you can see like benches and chairs, which is inside this building, and like windows, 2 windows and a door. Okay. So I'm just going to do this. Okay. So you can see here, once I get into the software, it's first asked me once I get into the room planning, it asks me first about what type I'm going to choose. So you can, once you place the mouse here, you can see like create empty rectangular room. Or if you want to create a free form shape. So I don't want to create a rectangular or a square room. I just want a room of a free form, a free shape. So I can use this option. So now I want a rectangular room. So I will choose this option. And you can see like spaces, right? Once you get into the spaces, you can see like education premises, like education buildings, offices, and healthcare premises, which comes under like dentist room or an eye examination room or an ICU room and a scanner room and so on. So, as I already said, though there are some standards which has been incorporated by the dialog software. So these are the standards which is comes under the European version 124641. Okay. So you can see like different rooms. So now I'm going to choose the education premises, so you can see like education buildings. Okay. So you can see once I choose this education buildings, it asks me in specific. So what type of an application it is, whether it's an art room or a classroom or an entrance hall or something like that. So I'm going to do for a classroom now. Okay. So I will choose the classroom. Okay. So, and it asks me, and 4 more things. It asks me about the length of the room, the width of the room, the height of the room, and the wall thickness of the room. Okay. So yeah, we'll get to here. You can see here, the length of the room is about 9.46 meters. All the dimensions is given in millimeter. You can see here, all the dimensions are given in millimeters. So to convert into meter, I just have to divide it by 1000. Okay. So you can see here, the whole length of this room is about 9.46 meter. And similarly, this width of the room is about 6.21 meter. Okay. So, and the height is about, you can see here, the room height is about 3 meters. Okay. So, and similarly, you can see here, the wall thickness is, it is asking me in separately. The length is asking length, width, height, and wall thickness, it is asking me separately. So what I have to do is I have to exclude the wall thickness and I have to only include the indoor length of the room, okay, and not the outdoor length of the room. So for example, you can see here, the indoor length of this room is about 9 meters here. So including the wall thickness, it is about 9.46 meter. But excluding this wall thickness, the indoor length is only 9 meters. So I've given here 9 meters. Okay. So similarly, you can see here the width of the room. The width of the room is about 6.21 meters. But this is only including the wall thickness. But I just want to exclude the wall thickness. Okay. So you can see here that the wall thickness is about 0.23 meters. Okay. So 0.23 meters on the both sides. So 0.23 plus 0.23 is 0.46. So 6.21 minus 0.46 is nothing but 5.75. Okay. So I've substituted here 5.75. Okay. So similarly, the room height is 3 meters, which is given here. Okay. So I will substitute this room height as 3 meters. Okay. Similarly, the wall thickness of the room. You can see the wall thickness is about 0.23 meters. So I've given 0.23 meters, and let me give OK now. So in the meanwhile, if you have any doubts, you can ask me. Okay. I've joined with my colleague, Mr. Manikandan. So yeah, he's also an expert in dialects. So if you have any doubts, you can ask both of us. Okay. So yes, once the software is opened, you can see like this. Okay. So you can see here the construction part. This is the construction part. We are in the construction part, and the second one is the lighting part. Okay. So we'll introduce you about one by one. So first in the construction part. Okay. So this is the 2D view. So if you want to view it in 3D, you can view it in 3D. Okay. So you can see here. So similarly, if I want to view it in the front view or a back view or a side view and so on, I can explore these options. Okay. So similarly, for example, you can construct a number of buildings here with the help of stylus. Okay. So if I'm constructing a whole site, which includes different types of buildings, I can use this option to use the whole site, to view the whole site. Okay. So similarly, if I want to view a particular building, I can use this option. You can see the building. Similarly, if I want to view a particular floor inside a building, I can use the story option. Okay. So these are the different floors inside this particular buildings. So room is nothing but the particular room in the particular floor. Okay. It's nothing but a room. So if you want to view it as a room, I can view. Okay. Yeah. So you can see here, there is some option called zoom to entire scene. You can see like, I think I have explored these options, and this is nothing but 3D view and a 2D view. Okay. So similarly, you can see like 3 more of the options appearing here, and it says zoom to entire scene. So if I go somewhere from my scene, I just want to get back to my scene, I can use this option. You can see like zoom to entire scene. So once I click it, it will get back to my scene. So similarly, you can see like tape measure. So if I want to measure the particularly the length or a breadth, so we have given about I think 9 meters for this, the indoor line. So you can see here it is about exactly 9 meters. So the width is about 5.75. So you can see here it is about exactly 5.75. So similarly, the wall thickness is 0.23. It is 0.23. Okay. So this is the tape measure option. So similarly, you can see like coordinate axis, set coordinate system. So you can see this coordinate system here, the x-axis and the y-axis. Okay. So I will tell about it more in future. Okay. So you can see here, this is the site option. So if I want to, import the AutoCAD file here, once I get into it here, I can even import the AutoCAD file here. So if I click this option, it will get back to, it will load to my computer, so I can import my AutoCAD file. Okay. So this is the whole site part. So if I want to draw, different buildings here, I can use this option. So if I want to construct a new rooms in the particular story, in the particular floor, I can use this option. Okay. So what I will do now is, you can see here, I've given the length, width of it, and given the height and so on. So first I will do is I will import the door here. Okay. So let me get back to dialects. You can see here the fourth option. The fourth option from here, from the first, you can see like something like aperture. Okay. So once you click the aperture, you can see like this window appears like here. So we go to select. Yeah. Once you go to select, you can see like doors and windows here, different types of doors and windows. So what I will take is I will take a door here, and you can see this option like draw new building open. Okay. So I will click this option and I will place it here. Okay. So you can view it in 3D. Yeah. Okay. So yeah, if I want to, once I click this imported this object, once I click this object, you can see like 3 more options will appear here. Like the first option is like move. So if I want to move this object, I can move it. So if, for example, I have to place this tool here, I can place it. Okay. So similarly, if I want, to rotate the door, okay, I can rotate the door. You can see like the option like rotate. So once I click that, you can see the blue dot here. So once I place my cursor here, it can rotate. Okay. So similarly, there is another option called scale up option. So if I want to increase the length or a width of this door, I can use this option. You can see like I can increase it. Okay. Okay. So you can see here that the width of the door is about 1.2 meters. So what I will do is once I click this door, you can see the dimensions here. It says the height of the door, the width of the door. So I have to make it as 1.2 meters here. Okay. So similarly, what I will do is let me place these 2 windows here. So let me go to select again in the aperture, and the same option aperture. Yeah, I can see windows, different types of windows. I will choose the simple window. Okay. So let me go in to draw new building opening, and let me place the window here. Okay, let me, yeah, okay. So once I go place the window, you can see here, it says me that the window's width is about 1.5 meters. So what I will do is let me click it, and you can see the width here. Let me make it as 1.5 meters. So similarly, it says me, what? Let me rotate it for my convenience. Yeah, you can see here, from this window wall, my window is placed about 2 meters. Okay. From this window wall, this window is placed about 2 meters from this window wall. So what I will do is, you can see here, my coordinate system is placed here. You can see this coordinate axis. Okay. So similarly, when I click any object, apart from dimensions, you can see another option called position. Okay. You can see like from the x-axis, how much it is positioned, from the y-axis, how much it is positioned, and similarly from the z-axis, how much it is positioned. So it basically calculates from this coordinate axis. Okay. So from this coordinate axis, this window is placed about 3.1 meters. Okay. So if I want to see it precisely, it calculates from this coordinate axis to this middle of this object. Okay. So if I want to give more insight about it, you can see like move option here. So once if I click this move option, you can see like this the coordinate axis of this object appears at the middle. Okay. So basically the software calculates the positioning from this coordinate axis to this coordinate axis. Okay. So my software says from this coordinate axis to this middle of this object on the x-axis part, it is about 3.1 meters. Okay, do you get my point? So here I can see here I have to place it about 2 meters from here. So what I have to do is I have to add 2 plus half of this object. No, so half of it is about 0.75. So 2.75. Okay. So I have to substitute here in this x-axis 2.75. Okay. So let me check it. Let me go to the tape measure. You can see here it is exactly 2 meters. Okay. So whenever I want to place in any object from the from this coordinate axis, what I have to do is I have to take the half of the object and plus the distance. Okay. So yes. So similarly, you can see like there is another window here. Okay. So what I will do is let me copy it. You can use the Control C option. And the dialects comes up with another option called Control M. So instead of, we generally give Control V for paste, right? So instead of giving Control V, you can use Control M option so that my object will get placed on my mouse pointer itself. You can see I'm placing my mouse pointer here. I'm giving Control M now. Okay, so it is getting exactly placed on the middle of my mouse pointer. So similarly, what I have to do is I have to place this window from 2 meters from here. Okay, so what I will do is let me place this coordinate axis from here to here. So you can see like set coordinate system. Let me take this coordinate system. Let me place it here. Okay, and let me click this object. So I'm clicking this object. So you can see here, I have to make this positioning as 2.75. As I already said, this distance, this distance plus half of it. So simply copy this and paste it here. So this width is same as this width. So half of this 1.5 is 0.75. So 2.75. 2 plus 0.75 is 2.75. So yeah. So let me click this object. You can see here. Let me just 2.7. So let me check it. Let me go to tape measure. Please just so you can see here it is exactly 2 meters. So far, do you have any doubts? I'm audible, right? Hello, am I boring? Hello. Okay. Oh, sorry. Okay, thank you. So if you have any doubts, can ask me. So okay, I will proceed now. Okay, thank you. So similarly, what I will do is, let me place these tables and chairs. Okay. So let me go to, I can see here this option like furniture and objects. From the bottom, it is about 6th option. You can see like furniture and objects. So once I click that, you can see like select option. So once I get into select, these window appear here and you can see here, go to catalog. Okay. So once you get into the catalog, you can see like object catalog. So once I double click that, a separate window will appear. Okay. So you can see here, I just want to place a table now. Okay. So let me go to the home furniture. So yeah, you can see here like tables. Okay. So we take in standard table. Okay, let me take this table. So once I double click that, it should appear here. It should appear in the background. Yeah, you can see here like active object. This table is appearing here. So I will close this now. And you can see like different arrangements like rectangular arrangement, polygonal arrangement, circular arrangement, line arrangement, so on. So let me explore all these options. So let me first go to rectangular arrangement. So yeah. As you can see here, the tables are placed in the whole rectangular part. So similarly, polygonal arrangement. So if I want to place it somewhere in a polygonal, okay, something like this. So yeah, sorry. You can see here. So if I want to place it polygonally like this, I can place it. Similarly, you can see a like circular arrangement, you know, like similarly like line arrangement. Okay. So you just explore all these options. Okay. So what I will do now is you can see here there are about 4 benches here. In total there are 5 benches. Okay. So let me place this first bench here and let me copy it and paste it. Okay. So let me go to place individual object. You can see like an option called place individual object. So let me click that and let me place it here. Okay. And it says me that the the length of the table is about 3.25 meters. So let me make it as 3.25. You see like the size. Once you click this object, you can see like the size. Let me make the size as 3.25. Okay. And similarly, the width is about 0.6 meters. You can see here, width is 0.6. So it is already 0.6. Okay. So what I will do is let me just rotate it. Okay. You can see this option rotate, and let me rotate it like this. Okay. So now I can move. So you can precisely see here, what I have to do is, I have to place this table from this indoor wall about 1.25 meters and from this indoor wall about 1.25 meters. So what I can do is let me rotate it for my convenience. Okay. So here you can see in the x-axis, I have to place this, this table about 1.25 meters. Similarly, in this y-axis, I have to place it about 1.25 meters. So what I will do is similarly, how I changed to rotate it here, I will simply rotate here also. How can I do it? With the help of this coordinate system. You can see the set coordinate system. It means set the coordinate system here because I'm going to, place this table from here, right? So I'll place it here in the indoor wall. And what I can do is let me rotate it to 180 degree. Okay. Okay. So you can see here. Now I have to place here about 1.25 meters from here from this table. Okay. So the same rule which I've already said, half of this object plus this distance. So you can see here the half of this width is about 0.3. So 0.3 plus 1.25 is about 1.55. So I will click this object and we go to positioning here. You can see here this x-axis is about 1.55. Okay. So similarly, you can see here, this distance is about 1.25. So half of this, so if we take a calculator, yeah, you can see here half of this. Okay, so 3.25 divided by 2, so what I get is 1.625 plus 1.25. Okay, so 2.875. So the same rule as I already said, half of this plus this distance. So what I get is 2.875. So I have to substitute here in the positioning 2.875. Okay. So if I want, I will check it. Go here, see it is exactly 1.25. So similarly, here it is 1.25. Now, so now what I have to do is I have to just copy it and paste it 3 more tables. So we'll just let me give Control C and Control M. So instead of doing it one by one, what I will do is let me just select it on the whole. So what I will do is let me give shift and let me select it. Okay. So in this y-axis, as I already said, I have to place it about 2.875. Okay. So I have placed all these 4 tables here about 1.25 meters from the center over. Okay. So similarly, what I have to do now is I have to place this table about 0.75 meters from here. Okay. So what I will do now is let me place this coordinate system here. Okay. For my convenience, I will place this coordinate system here. Okay. So here, what I have to do is 0.75 plus half of this 0.3, which is nothing but 1.05. So let me click this object, and in the positioning, we give it as 1.05. Okay. So similarly, it will place the coordinate system here, the same distance for all the tables. So let me click this, and let me make it as 1.05. Similarly, let me place the coordinate system here, and let me make it as 1.0. So yes. So what I will do is let me place the chairs now. Okay. So let me go to the dialects. You can see here the same option in furniture and objects. You go to select catalogs, object catalogs. So you can see here office furniture. So in office furniture, you can see like chairs. Okay. So you can see different types of chairs. So let me choose a simple chair now. Okay. So let me double click this. You can see here it will appear here. Okay. So what I will do is I cannot place it individually. So I will do is I will take a line arrangement. You can see here I will place a line arrangement here. Okay. So what I need is about a 5 chairs. So you can see here once I place the line arrangement, it will ask me a number of objects. So let me make it as 5 now. Okay. So similarly, I can just copy it and paste it on the 4 sides. Okay. So let me give Control C, and Control M, and Control. Okay. So, but you can see here, I think it is upside. See, all the chairs are, facing here. I just want to face it here. So what I will do is I will just rotate. I could have done it earlier. Before copying it, I could have done it. Okay. So, okay, so you can see here. Now place the tables and the chairs and the windows and the door. Okay. So let me go to 2D again first, and let me give the color to the, to the building. Okay. So you can see here materials. Okay. The second option from the furniture and objects, the other option is the materials. So if we go to materials, we go to select now. In the select, you can see here catalog, go to catalog, and you can see like 2 different catalogs. One is the material and the other is the color. So first let me go to the material and show you. Yeah, in material you can see like indoor and outdoor. So we go to indoor now. So yes, once I get into the indoor, you can see like floors, different materials for floors, like tiles, different types of tiles. Okay. Or even a grassy area, or when I go to outdoor, it will be like a grass area, mud and so on. Okay. So if I go for a ceiling, you can see like, yeah, I can see window, like different types of windows. So I can just use this materials to import it on my diagram. Okay. So let me go to floor now. Okay, let me choose this concrete. You can see like apply material. So once you click the apply material, once you choose it, it will appear here. So once you give apply material, you will see this the paste option, the paint option. So you go to the floor area and paste it. Okay. Okay. So similarly, I have to give the coloring to the walls and so on. So let me go to the catalog again. You can see like window. Okay, so let me choose this window. We choose this window and okay. Yeah, it appeared here. So let me go to the okay. Let me go to the window and just give apply material. Okay. So I could, I should have chosen I should have chosen a rectangular, the window with a mullion, but I've chosen the single window. Okay. So let me go here. I can adjust this. Okay. So yes. So similarly, let me give the color to the walls and so on. So firstly, we go to doors now. You can see your doors. Let me choose this door. And let me give apply material and apply. So place the door. Okay. So similarly, color. Let me go for a color now instead of a material. If you go choose the material, select catalog and select color. Okay. So yeah, let me give a blue color. Okay, let me choose this. We give apply material. Okay. So now I've given the walls, the doors and so on. So what I have to do is I have to give the coloring for the tables and chairs now. Okay. So instead of going into the catalog for the color, I can even choose a color from here. You can see like this option, or you can choose like create color material. So once I click the create color material, this option will appear here. So I can choose any color from here. Okay.
Sir, excuse me, sir. Your sharing website has been stopped. Screen.
Okay. Yeah, is it visible now?
Yes, sir. Perfect.
Okay. Yeah, I hope you have seen it. I've given color for the walls, the doors and the windows and so on. Now I have to give the color for the tables and chairs. So what I will do is let me choose a color. Let me choose a light color. Okay. So let me give apply material. Okay. So similarly, I have to give a color for the chairs. So I cannot give individually to all the chairs, right? So you can see like an option called replace material. So once I click this replace material and give the color, all the objects will get replaced with the same color. Okay. You see all the chairs gets replaced with the same color. Okay. So this is all about the construction part. Okay. If you have any doubt, you can ask me, or else you can move to the lighting part.
Participants, please post your questions on chat box.
I think the screen was not visible for a few minutes. So if I want to say something again, I can say it again. Okay, I don't want to waste my time. Let me move to the lighting part now. Okay, thank you, Purnima. So yeah, you can see like lighting. So this is the important part. So let me come to the lighting part. You can see like light. Okay. So once I get into light, you can see like this window will appear here. Okay. So let me come from one by one. Okay, you can see like Lumina. The first option is Lumina. So as I already said, you first go to the manufacturer part and download the different, any one catalog. I prefer you to download the Philips catalog. Okay. So go to here and yeah, I think you can see like Philips catalog. Okay. So we go to light again. Yeah, I will choose a light. So let me go to select again. You can see like select option. Let me go to catalog. I have my Philips catalog installed. Okay. So let me go with the Philips catalog. So or else, if you have any problem in installing the catalog, the lighting catalog, there is an option called LEM search. Dialex comes up with an option called LEM search. All the lighting manufacturer data is combined, is aggregated into a this option called LEM search. I will just show you now. So before that, I will choose a luminar for this indoor lighting design. Okay, so let me go to indoor now. You can see, let me do choose a downlight. Okay, so let me go to this clear accent. So let me choose a low level lumen. Okay, for now. I will tell you why. So I will, yeah. Once you click that and give add. Okay, so and it will appear here. Yeah, okay. So as I already said, you can see like select, you can see like LEM search. So once I click this LEM search, it will get me a browser. Okay. So this option will be only available if you have an internet connection. Okay. So once I click this LEM search, it will get to the browser. Yeah, and you can see like you can choose the Lumina here. Okay. So if I want to go for an indoor or an outdoor Lumina, or if I want to go with the manufacturer, I can explore here. If I want to search with a, I just want to choose a luminar with specific IP rating or with a specific watt or a specific lumen, I can search it here, or else I can go with this option. You can see like indoor. So let me go. Yeah, you can see like once I get into indoor, you can see like these are the different type of mounting fixtures. Okay. So ceiling resists nothing but the lighting, which is fixed on the ceiling, which is fixed inside the ceiling. Ceiling surface is nothing but the lighting which is fixed onto the ceiling. Okay, and the pendant is nothing but an hanging fixture. Similarly, standing and the wall surface mounted and so on. Okay, you just explore it. If you have any doubt, you can ask me later. Okay. So let me get back to the dialects now. Okay. So you can see here I've chosen this luminar. So what I will do now is let me go to 2D now. And you can see like an option called draw rectangular arrangement. Okay, so let me choose the rectangular arrangement and let me place it on the whole indoor part. Yeah, you can see here, the luminars has been imported here. So once I drag it down, you can see like, the lighting which is used, the name is appearing here. And similarly, how much number of luminars which is on the x-axis and the y-axis of this room is appearing here. Okay, there are total about 42 luminars which we have imported here. So you can see here for a small room, there are about 42 luminars, which is very great, right? So this is because I've chosen a very less lumen. I've chosen, you can see here, I've chosen only a 6 watt 500 lumen. 6 watt of power consumption, and only a 500 lumen, which is very less. Okay. So I've chosen this because, you can see here, like there are about two planning types. And one is about illuminance and the other is about uniformity. So uniformity is nothing but, so let me go back to the PPT. Yeah, you can see here uniformity. Uniformity is one of the important features. So it is nothing but how uniform my lighting is inside my building. It is typically calculated by minimum elements which is achieved on the building, on the working plane, divided by the average elements. Okay, which is nothing but the uniformity. Okay. There is also another type of uniformity which is nothing but minimum elements by maximum elements. Okay, but we always prefer this. We always calculate this. Okay. So we go here. Yeah, so once I give importance to illuminance, if I give importance, you can see here the illuminance option is enabled now. So if I give importance to illuminance now, the number of luminas will increase so that my target will get achieved. Okay. So before that, we give an insight to it. So yeah. So this is an indoor lighting design. I think you would have heard about the lumen method, right? You could have studied the lumen method. Lumen method is nothing but to calculate the number of lighting fixtures for a given room. Okay. So you can see here the capital N is nothing but the the number of lighting luminas, the luminas required for a given room, which is equal to E. E is nothing but the illuminance into A. A is nothing but the area of the working plane divided by N. The small n is nothing but the number of lamps in each luminar. As I already said, a luminar may contain more than one lamps. It is not necessary that a luminar contain only one lamp. Okay. So small n is nothing but the number of lamps in each luminar, and the luminous flux SF is nothing but the luminous flux, and EMF is the maintenance and the utilization factor. Okay. So we'll tell about it in clearly. So yeah. So generally, if I want to say, for example, I'm doing a lighting design for a switchgear room. Okay. So for an indoor switchgear room. So if I want to do the lighting design, the illuminance level to be achieved on the given, on the switchgear room will be given by the customer, or else I have to refer to the standard. Okay. So it depends upon the application. For example, so if I say a classroom, classroom will comes with more visual part. Students will be studying here, writing, listening, and so on. So the illness level will be generally high when in a classroom. So for example, or else if I go for an, for example, I'm doing a lighting design for a corridor or a railway platform or a bus stand. Okay. So the illness level is not, I don't need much illness level when compared to a classroom. Okay. Say for example, yeah, you will get a better idea once you can see here. Say for example, for public areas, it is about only 20 to 50 lakhs. So if I say for an area like stairway, escalator, so in that areas it is about 100 lakhs. So if I go for an working areas, where a visual part is required, so it is about 100 to 150 lakhs. So yeah, I can see like coffee rooms, technical rooms and so on, 200 lakhs. So if I go for an office area, the working areas, it is about 250. If it's a classroom, it is 300. So yeah, I can see like groceries and showrooms about 500 lakhs and so on. Okay, so we'll get a better idea about different elements once you see this this chart. If I different, it depends upon the application. If I go for in a public area, and it is okay if I go, it is about 20 or 50 lakhs. So if I go for an surgical room, okay, a surgeon is operating in an ICU room. Okay, he needs a very good lux, to do the operation successfully. He needs a very good lux. So it will be in the range of 5,000 or 10,000 lux. Okay. So it depends upon the application. So depending upon the application, the ailments level will vary. Okay. So either this will be, we have to refer to the standard, or it will be given by the customer. Okay. So similarly, A is nothing but the area of the working plane. Okay. It is nothing but the length and the breadth of the working plane. So similarly, N is nothing but the number of, as I already said, the number of lamps in each luminar. Luminous flux is nothing, the luminous flux which is emitted from the lamp, the lumen. Okay. So as I said in this example, we have chosen about a 500 lumen. Okay. So similarly, the maintenance factor and the utilization factor. So let me tell you what is maintenance and the utilization factor is. So maintenance factor is nothing but, let me give you an example. For example, let me do I've constructed a new building and I've given a new luminas inside the building. Okay. See, for example, after a period of 6 months or 1 year, the lighting which is experienced on the initially will not be same after 6 years. I mean, for a 6 month or 1 year, right? This is typically because of the light loss factor, the maintenance factor, because there will be some light loss after the sum of hours of use of the Lumina. Right? Say for example, the lumen which is produced initially, say for example, the lamp produces about 500 lumen. Say for example, after a period of 6 months or 1 year, it will not be same. There will be some drop in the lumen. Okay. So similarly, the second is nothing but the dirt which is accumulating on the lumina. There will be some dirt which is accumulated on the reflectors of the luminar or the covering part of the luminar or something like that. So because of the dirt, there will be some loss in energy. There will be some loss in luminous energy. Okay. So similarly, the dirt which is accumulated on the reflectance of the room surface, like the ceiling part or the walls or the floor cavity. Okay. So because of this dirt accumulated on the reflectance, there will be some light loss. Okay. So this is nothing but the maintenance factor. So these three factors you can see here. Yeah. You can see here the maintenance factor is decided by the lamp lumen maintenance factor, which I already said. Due to hours of use, there will be some drop in the lumen produced by the lamp. That is nothing but the lamp lumen maintenance factor. Similarly, luminar maintenance factor, the dust which is accumulated on the luminar, and similarly the dust which is accumulated on the room surface. So these three factors decide the maintenance factor. Okay. So typically, if it is a well-cleaned room, say for example, I'm cleaning it for a regular interval, it will be in the range of 0.8. Okay, it normally ranges from 0 to 0.1. Okay, this factor, the maintenance factor ranges from 0 to 1. So yeah, if it is a well-cleaned room, it normally ranges in about 0.8 or 0.7. Okay. So similarly, there is something called utilization factor here. You could have seen here. Yeah. So now we have discussed about the maintenance factor. So now we'll discuss about the utilization factor. So utilization factor is nothing but the light which is producing from the luminar. Yeah, the light which is producing from the luminar will not be the same when it achieves on the working plane. You get my point? The light which is producing from the luminar will not be the same when it achieves the working plane. There will be some loss during the during the day. This is nothing but I will explain in detail. Okay, so you can see like light output ratio. So first let me explain this. Yeah, you can see like light output ratio. The light which is produced from the luminar will not be the same when it passes from the the lighting covering. Say for example, let me take a tungsten lamp. Okay, the light which is produced from the tungsten filament will not be the same when it passes out from the light covering, from the glass covering. There will be some loss when it passes through the glass covering. So that is nothing but the light output ratio. Okay. So similarly, you can see like the flux distribution. Say for example, the light which is produced directly, the light which achieved on my working plane directly from the luminar is nothing but direct lighting. So similarly, there is something like indirect lighting, semi-indirect lighting, and so on. You can Google it. Semi-indirect lighting is not indirect lighting is nothing but say for example, the light which is getting reflected from the ceiling will get reflected back to my working plane. So that is nothing but indirect lighting. So this, the reflectance. So because of this reflectance, there will be some loss in the light. So that is nothing. So it also affects the utilization factor. So similarly, the room proportion, the room reflectance. For example, if I paint, my wall with a black color, black absorbs light, right? If I play, paint my wall with a black or a dark color, most of the light will get absorbed.
So thank you, sir. Thank you for the speech. Just sorry for the disturbance. Can we close in 5 minutes, sir? You can share your contact details to the participants, sir. So we can we close
okay.
it 5 minutes?
Okay.
Okay, sir. Thank you. Thank you, sir.
Okay. Yeah, if you want to contact me, you can contact me in the group. So I think I should have given you an outline. Okay, I'm sorry.
It's
So
okay, sir.
okay.
It's okay. The participant, if you need any last question to be done with, so you can put it in your chat box. Now, if you have any last questions, sir will contact you personally, or he will give you the phone number or email ID as well.
Yeah. Okay. So
So
yeah,
you
if you
just
want,
give a phone number or email ID in chat box, sir.
my number is in the group itself. I think Sarah's added me. So yeah, I will. So if you have any doubts, if you're really interested in this lighting, you can contact me. I will give you my mail ID here. Okay. I posted my mail ID in the chat box. Okay. My name is Sargunan. So if you want to contact me, you can contact me. Okay. Okay. So yeah, my number is okay. I've given my contact number also. So yes, if you're really interested, you can contact me so that I can help you. Okay. So thank you so much. Thank you for giving me the opportunity. Okay.
Thank you, sir. Thank you for the session. Sorry to interrupt, sir, in the middle.
Okay, sir. Thank you so much. Okay.
Thank you. Thank you, participants, for your time. Just you got the outline of the software where sir has introduced the software. Please practice with, and if any doubt, you can contact with him. And while practice only, we will get doubts or doubts. So sir will help you in any questions, whatever the question may be. Thank you very much for the participants also. Thank you, sir. Have a
Okay.
nice day.
Okay. Thank you.
Thank you. Bala sir, you can exit the group, sir.